Hello, good afternoon. So today I'll be talking on equation in two variables, and the subtopic will be finding equation of a line. I'll be talking on equation. I'm talking on inequalities in one variable, first degree equation, but today I'll be talking on equation in two variables, and the subtopic will be finding equation of a line. So, to write the equation of a line, it is necessary to know the slope and the y-intercept. There are three possibilities which depend on the data available. To write the equation of a line, we must first know the slope and the y-intercept. And we know our slope is m, and y-intercept is what? Is b. Sometimes it's what? C. So number one possibility. Possibility one. In a case, both the slope and the y-intercept are known, and the equation can be written directly. It is in a case where both b and m are known, so we can just write the equation directly. Now, say for example, if the slope is -2 and the y-intercept is 0 and 6, when the equation is y, if the slope is -2 and the y-intercept is 0 and 6, then the equation is y equals to 6 minus 2x. Why is like this is that I explained here. This is y is equals to mx plus c, mx plus b, or mx plus c. These are the equation of a line, and this is our c, or you can call it b, and this is our what? Our m. This is our slope. Here is our slope. Here's our intercept. So you cannot impute your slope and your intercept into your formula, into the equation already. And possibility 2. In this case, the slope and one set of coordinates, this is what they call coordinates here. What they call coordinates, x and y coordinates. These are x coordinates and y coordinates. In this case, the slope and one set of coordinates are known. This case involves the use of the point slope formula. In the case where possibility 2, in the case where it gives us the slope and one set of the formula, we are using a point slope formula, and these are the point slope formula. Change in y equals to delta y over delta x is equals to y1 minus y2 all over s1 minus s2 is equals to y2 minus y1 all over x minus s1 is equals to y minus y1 all over x minus x1. All this stuff I just mentioned now, they are all the same. There's no difference in them. They are all what? They are all the same. So here is the final term. X1 and x2 are known coordinates. Here is the final term. X1 and y1 are the final terms. They are what? Known coordinates. And x and y are unknown coordinates. Therefore, the slope can be given as what? This. Y minus y1 all over s minus x1. So this expression is the point slope formula. It can be rearranged to produce a working version. So now when they give you only the slope and one coordinate, you're going to use this formula to solve it, because these two are unknown and these two are known. And I'm going to give you only s1 and y1. There's one coordinate. They're going to use this formula here to solve it. So you see, y minus y1 equals to b, open bracket, x minus what, x1. You can interchange it depending on, you can rearrange it to a version that will work out for you. Having y equals to y1 plus b all over x minus x1 to make y stay on its own. We are looking for y. We are looking for this y here. On. That's what happened there. That's why we interchange it, collecting like terms and stuff like that. Okay, now an example. Find the equation of a line which has a slope of 4 and a set of coordinates 3 and minus 2. Find the equation of a line which has a slope of 4 and a set of coordinates 3 and minus 2. This is x and this is y. X coordinate, y coordinate. So you see, this is something dealing with. This was what we are going to use the slope, point slope formula for. So here our x1 is equal to what, 3, and our y1 equals to what, minus 2. Now using this formula now, the point slope formula, we are using this one here. So we're having y equals to y1 plus b, open bracket, x minus x1. Y is equal to minus 2 plus, our slope is what, 4, open bracket, x minus 1, 3. Our y is equal to minus 2 plus 4x. This x now multiplied everything inside this bracket, minus 4x minus 12. 4 times 3 is what? 12. Our y is equal to what? Minus 14 plus 4x. The same thing as telling me y is equal to mx plus c. So you can rewrite this one now as y is equal to 14x plus open bracket minus 14. That's equation of a what? Of a line. Now going back here to possibility 3. In this case, two sets of coordinates are known, but the slope is not known. This case involves the use of 2-point formula. Since the slope of a linear function is the same at any point on the line, we may set an expression for the value of the slope at one point equal to the value of the slope on the other point. Now this is a 1 point slope formula. This is a 2-point formula. y2 minus y1 equals x minus s1. In a graph, let me draw the graph. So this is the graph. This is our y-axis. This is our x-axis. This is our y1, y2. This is our x1, x2. This is a slope. What do we call a slope in the graph? This is slope in the graph. And this is an intercept. When the angle comes out from here, this is an intercept of the graph. Okay, this expression is a 2-point word formula. So now, this is the next example now for what possibility 3. And they find the equation of a line which passes through the point minus 2 and 3 and 3 and 8. Our x1 is minus 2, our y1 is 3 here. Our x1, so our x1 is minus 2, our y1 is what is 3. Our x2 is 3, and our y2 is what? Is 8. So now, this is the 2-point slope formula. All this stuff here, everything here is a 2-point slope formula. Everything here is So see the slope is equals to y minus 3 all over x minus 2x. That's our x1, our y1, our x1. Is equals to 8 minus 3. This is y2 minus y1. 3 minus 2. This is x2 minus x1. As it is in the formula. So that is equal to, looking for our slope, don't forget, y minus 3 all over x plus 1 plus 2 equals to 5 over 5. 8 minus 3 is 5. This plus gives us 5. If 5 divided by 5 is what? Is 1. Slope is equals to what? Y minus what? 3 is equals to what? X plus what? 2. How did you get this? Now come here now. You have been y minus 3 over x plus 2 is equals to 1. We cross multiply this 2, come and make this 1 here to give us this stuff. To give us y minus 3 is equals to x plus 2. But not finished there. We went down further to break it down. Collecting like terms. Y is equals to what? X plus 2 plus 3. So y is equals to what? X plus what? X plus 5. So only looking at this stuff, I only got to an equation of what? Equation of a line. Now say the equation of a straight line is usually written this way: y equals to mx plus b, or y equals to mx plus c. Now you know that this one is equation of a straight line. They still have equation of a parallel line, equation of a perpendicular line, but now we are dealing with what? Equation of a straight line. Now, what does it stand for? Now I'm done with possibilities. Now, what does it even stand for? This is our graph. Now, what does it even stand for? This is our graph. This is our m, this is our b, this is our x, this is our y. Y-axis, x-axis, and so. So you see y equals to mx plus what? B. Well, mx is what? Our slope. Our b is what? Our b is y when x equals to 0. And it's called what? The intercept. Now, our y is how far up. Now, that is this line. How far up is going. Our x is how far along is going. Our m is the slope. And our b is the value of the intercept when the slope crosses the y axis. That's what our intercept is. See, so now the next is, how do we find m and b? That's the question now. How do we find m and b? B is easy. Just see the cross line, the line that crosses the y-axis. So I told you here, you can get b easily. Just see this line now crossing this y-axis. Now our b is 1. Intercept is what? Is 1. Anyway, the line crosses, the figure that crosses, that is what? The y-intercept. But our m, our slope, the slope needs what? Calculation. To get our slope, we always need to what? Calculate. That's why our formula came in. M equals to change in y over what? Change in x. And this is it, change in y, change in what? In x. This is where our whole slope of a thing, the whole formula came out from. You can't just get the slope without calculating, except the equation gives you the slope. But in the case where they don't give you a slope, you must always find the slope. That is change in y by change in x. Same thing as y minus y1 over x minus x1, or y2 minus y1 over x2 minus x1. This is just free formulas. Some formulas you must know when finding your slope. When slope is not given, you must know this formula. When slope is not given. So now, there's a question actually here. You see, there's an example here. You see, find the equation of a line that passes through the point 5, minus 5, and 2 with a slope of minus 3 and 4. They give us the slope. That's this formula now. That one we used the first time. Y equals to y1 equals to mx y minus y1 is equal to mx all over open bracket x minus x1. Y minus 2 is equal to minus 3 over 4. X minus 3 over 4. I'm not putting our slope now here. This is our slope, our m, our slope. Our y1 is minus 2. Open a bracket, our x goes to minus open bracket minus 5, close bracket, minus 5. That will make it positive or positive 5. That's our x1. To clean up, we will multiply both sides by what? By 4. 4 here will give us what? We multiply it by 4 and multiply only this bracket by 4. Only the first bracket, not the second bracket. Now having 4 times y is what? 4y. 4 times minus 2 is what? Minus 8. Equals to 3 times. Now if you come here, this 4 here, remove this 4 here. Now having minus 3 into what? X plus 5. 4y minus 8 is equals to 3 times x will give us what? Minus 3x minus 15. Now we multiply 8 from both, we add 8 to both sides to remove this what? This 8. And when we do that, we'll be left with, when we do that, we'll be left with 4y minus 4y equals to minus 3 minus 7. Now to clear this, we added 3 to both sides. To remove this 3 here, we added 3 to both sides. 3 here and 3 here. This one will now go out. What we have here is what? 3x plus what? 4 equals to minus what? Minus 7. Or we divide both sides by what? 4. Divided by 4, y on its own, that will be equals to minus 3 over 4x minus 7 over 4. And that will be our final answer. It depends on how you want to actually leave it.